All right, I'm doing some power consumption testing with this Arduino Pro Mini board that I got here. And to start off with, when I plugged it in, an LED came on, so I immediately desoldered that. That was the power LED. And then also, like all Arduinos, they've got an LED on pin 13. Turns out that I'm going to be using pin 13 for the hardware SPI communication bus with the transceiver, and I don't want that LED to be consuming power, while I'm, working with the transceiver. So, but I want to see if I can leave that LED on the board. So I just cut the trace on the LED, and maybe I can solder a little wire from the resistor for that LED over to a different pin that I'm not using, and then I could leave that LED there for use later on. So that's how I prepped the board, and then I wrote just a real quick program that'll put the ATmega to sleep and wait for an interrupt. And when I hit the button here, the interrupt goes off, and I just plugged in a wire into the pin 13 and set up an LED on it. So I just turned this on for 10 seconds, then it just goes right back to sleep. So I did the same. I tested the same thing out on my development board, which is a bare bones board. It doesn't have a voltage regulator on it. And when I run this sketch on it, the power consumption for the bare bones board is 12 microamps when it's asleep and 12 milliamps when it's awake and it's got that LED lit up. And it's running at 16 megahertz. The Pro Mini at 8 megahertz, it is consuming 78 microamps and 8 milliamps when it's on. I think the 78 microamps is caused by the voltage regulator being on the board. So that's the big difference between these two. And then I think it's lower when it's on because it's running at 8 megahertz instead of 16 megahertz. So I plugged some numbers into the battery life calculator website. I put in just a 1000 milliamp battery and then that 78 microamps of current when it's asleep. And I don't know what the power consumption is going to be, but I just put in 1000 milliamps or 100 milliamps just to have a number. The kitchen timer only draws like 50 or less than that, actually 40. So hopefully it'll be a lot less than this. But anyways, I had it have it waking up 6 times a day, and then for 20 seconds each time. And if I put those numbers in, it comes up with 163 days that it would be able to run the controller. And if I were to change the sleep to be what the bare bones board does, it's 234. So that's not, that's better, but still 160 is really good. And I'm pretty encouraged that I could get by with just one of those LiPoly cells, 1000 milliamp pack, should run for 160 days or so. If I can get let me close that. If I can get this down to maybe 50 milliamps when it's on, that would be 240 days. So I think this will be okay the way it is right now. Here's it running right now asleep. It's consuming the 78. I'll wake it up, and here it's consuming 8.5. So pretty encouraging.